If you want Unity 3D, CryEngine, or Unreal Engine tutorials, like, comment, or subscribe for more. Today, we will continue with our How It's Developed series with episode 2. In this episode, we will be starting to create the player and player view classes. These two are integral components to implement to have our third-person camera to work appropriately. You may be asking why a third-person camera instead of a first-person camera. The reason for this is because we can tweak the values to become a first-person camera rather easily. If you haven't already, go check out episode 1 as it has very important code you need in order to make everything work later on. So let's sit back, relax, and get started with episode 2 of our How It's Developed No Man's Sky multi-tool tutorial in CryEngine. To begin, we should open the SLN file to load our project. Let's create a folder called Player. Inside of this folder, we create our player.cs and playerview.cs files. The first file we will work with is the player.cs class file. In this file, we can go ahead and remove all of the using statements as we have no need for them whatsoever. The reason we don't need any of them is because none of the code we will be writing will even remotely be needing them. We can now change the namespace to be CryEngine.game. We are doing this to keep everything organized as we did with the view camera class. We do need some inheritance here, and we will inherit from entity component. Now, entity component represents a component that can be attached to an entity at runtime and automatically exposes itself to schematic. More on schematic in a later video. We will now create a public boolean called inverse vertical rotation, which we will set to default to false. This boolean value inverses the vertical rotation of the camera. We have 6 public float variables to create. Move speed, which is set to 100.5 float. This will be the value in which the player will move by. Yaw speed, which is set to 0.002 float. This will be the speed where the player rotates on the horizontal axis. Pitch speed, which will be set to 0.002 float. This will be the speed in which the player rotates on the vertical axis. Pitch min, set at negative 0.84 float, the minimum value where the player can rotate on the vertical axis. Pitch max, which will be set to 1.5 float, the maximum value where the player can rotate on the vertical axis. Camera distance offset is 1.5 float. This offsets the camera from the player character. Save this, and let's go over to the player view class. We will create a few fields and method stubs so we can continue with the player class without producing any errors. The only using statement we will use with the player view class is using system. The namespace should be CryEngine.game for the same reasons as Y in the player class. The player view class should be public because we need to access it from other classes, such as the player class in this project. We will create 2 private read-only fields, player and entity. We will make sure that the player will be called _player and that the entity will be called _camera_pivot. This follows the proper naming standards. As for read-only fields, this denotes that we are creating runtime constant values. The last field we need is a private view camera and call it _camera. The reason we are doing this is because we need to have a reference to the camera class we created in episode 1. We have to create a constructor for this class, which we will call public player view with the parameters of player. Let's also create a public quaternion called updateView with the parameters of float, frame time, and vector2 rotation delta. And to make sure we don't generate an error, put return quaternion.identity. The last method stub we will create is a public void deinitialize. More on these 3 methods later when we implement them. This will allow us to continue on with the player class without generating any errors. Let's jump back over to our player script and continue on with implementing this class. We are going to add a private player view called _player_view. This will give us the reference to the player view class we will need in a little bit. Private string _input action map URL is set to the string value of lib/config/default profile.xml. This is the location of the XML file that we will create that will store the basic movement information. Private string _input action map name is set to the string value of player. This is the name of the entity that we want to use as well as specifies which profile we are using. Private action handler _action handler is next. Action handler is a C# wrapper method for accessing action maps. This allows us to have a config file that defines our input instead of hard-coding inputs, which goes back to the input action map URL's usage. Private vector2 movement is set to vector2.0. Vector2 takes an x and y value. Vector2.0 specifies that we want a default of 0 value for it. Private vector2 underscore rotation movement is set to vector2.0. We also want our rotation to have a default value of 0 for it. We have finished all the fields we need, and now we can get on to the nitty-gritty of writing our methods. Our first method is initializeInput, which will be a private void method type. This method will be for handling our inputs. Underscore action handler question mark dot dispose. This bears a bit of explaining. The question mark denotes in this case that the action handler is a nullable type. Nullable types can return true, false, or null. Dispose is a method that will clear the values and remove it. In this case, we are checking to see if it is null. If it is, dispose of it. Underscore action handler is set to new action handler with the parameters of underscore input action map URL and underscore input action map name is next. This creates a new action handler class that takes a string value for the action map we will be using and a string value for the name. What this does is tell the game where the action map XML file is located and for which profile name we want to use. Underscore action handler dot add handler for all of our various movements are next. This method takes a string for action and then a system.action with string, input state, and float values inside of it. So we want a total of 6 different movement types. Move forward, move back, move right, move left, mouse underscore rotate yaw, and mouse underscore rotate pitch. For each of these, we will call it onMove and designate which movements we want, which will be forward, back, right, left, mouse X, and mouse Y. Well, with all of that done, this wraps up today's episode. In the next episode, we will be continuing working on the player class. This has been Jesco the Rising Phoenix Dev, and I'm signing out. I want to give a warm and loud shout out to my first Patreon supporter, Coop! Thank you very much for your support, man. I greatly appreciate it. As always, the link to my Patreon and Discord server are in the description below.